Hi everyone. In this video, I'm going to discuss about client-side software that is required for rate limiter. So firstly, why do we need a client-side software? Why can't we just directly call the rate limiter service APIs? So if it is a REST API, we can directly call rate limiter service APIs without needing for any client-side software. So, but there is a disadvantage with REST APIs. So the disadvantage is so in a REST API, what happens is we will have a TCP connection, and then each TCP connection will handle one request at a time. So there is no concurrency here in TCP, and it will make our system slow. So the server, so the client, what from the client side, what happens is some code is executing, and then we suddenly see we need to send some metrics. So the code will stop, the client side code will execution will stop, and then a request will be a HTTP request will be placed, and then it reaches our rate limiter service, and then the response comes. And when the response comes, then only the next set of lines will be executed on the client side. So this is very costly. I mean, the time taken here is huge. So we have to reduce this time. So for us to reduce this time, the best way is use gRPC. So what happens with gRPC is the connection stays open even in HTTP. In the rest also the connection stays, the TCP connection stays open, but in gRPC at a time multiple requests can go and multiple responses can come at a time concurrently. Like parallelly these can happen, like multiple requests can be sent, and then multiple responses we can get from a single TCP connection. So that is the advantage with gRPC, and it is fast. You will as soon as we have a request, we will directly, it will most probably directly will go into go and hit the server, rate limiter server, and then we'll get an immediate response compared to REST. So it is better to use gRPC. So for us to use gRPC, the client, we assume that the client is running on netty, and even the server also should also be running, we assume that it is running on netty, and netty plus spring plus Kubernetes, and then all of this is running in an virtual private cloud. I mean, the rate limiter service has its own virtual private cloud, VPC, and then the servers are distributed around the globe. Let's say our rate limiter service is very huge, I mean massive scale, say all the YouTube metrics, or and all the Google Maps metrics, and all the Google Pay metrics are coming to our metric service, rate limiter service. So the scale is huge. So so this is the infrastructure I'm having right now. This is the setup that I'm having right now. We are using netty. We are using Spring for application for application development. We are using Spring, and then netty to establish gRPC connections, and then Kubernetes to orchestrate, and then all these clusters are connected by virtual private network, like virtual private cloud, VPC, in its own VPC. All of these clusters are in VPC, and then YouTube Google Maps, they are in their own VPC, and then these two VPCs are connected via a link, so that the YouTube or Google Maps, they can connect to our rate limiter service. So that is how the setup will look like. Um, so now we understand that we need to use gRPC and why it is better than HTTP. And the next thing is we need to send the metrics. So for us to send the metrics, we need to know what are all the functions that are provided by this rate limiter server. So all these functions are in a dot proto file. A dot proto file will define what are all the RPC APIs that are being provided by the server. So once we build the client side services, will be these RPC files, these proto files, these proto files will convert into Java code, and then a stub will be created, and with that stub we'll be able to call the start method, like ingest. We can ingest the metrics. So that is what I wrote in this first point. A proto file copy exists in both client and server, which has RPC API signature that can be used as contract between the client and server. In this proto, we define metrics batch, metric responses, classes, etc., and function as well, like report batch. This dot proto will generate files after build, which can be used to call server APIs. So in the second point, I was explaining the setup itself, the setup which I mentioned previously. So if you see the metric client, we have different functions that are being used, that we need, not even used. Like one is the start method. The start method will establish the gRPC connection, will request for a gRPC connection with the rate limiter service. So for a gRPC connection to establish, first it needs to authenticate. For us to authenticate, only registered service can only authenticate, right? That is our initial thought process. Like only registered service should be able to send metrics, and only those metrics will be tracked. So for me to detect like which service is sending the metrics, I need a we do an MTLS authentication. So MTLS is server to server authentication, where they exchange the certificates. Server will share its own certificate, and then client will send its own certificate, and then the server will ask whether this is valid certificate to CA, and then CA will sign that certificate, and then say if it is a valid client or not. So once this MTLS authentication is done, and we are able to now understand the client is claiming what it is, then we will check, then we will try to establish then we will try to establish the gRPC connection with the server. So that is step 2. That is what I wrote in the start method. We will establish gRPC connection with rate limiter service. So SSL connection, gRPC SSL connection to client. So using native, we will be able to we don't need to make any further changes. We just need to mention like on what port we want to connect, and then we just need to share the certificates. This creates a long-lived gRPC channel with rate limiter service verified over MTLS. So once we send all the metrics, we need to close the we need to shut down the gRPC connection, right? We need to close the connection. So we have to close it gracefully. Like if already we are in the process of sending some metrics and then we suddenly we forcefully close the connection, and the metrics may not reach the service, the rate limiter service. So we need to gracefully close the gRPC connection. For us to do that, first we say channel.shutdown, and then we'll wait for 5 seconds for the processes that are in the process in line, right? We'll continue them, but no new metrics will be sent. So this will shut down the gRPC connection gracefully. That means any in-flight RPCs will continue, like any in-flight APIs calls will continue. New call made after shutdown will fail immediately. So next is the ingest. So in ingest, what we need to do? In ingest, we can directly call the rate limiter service report batch and report batch the third party call, and then we will send the metrics, and then we'll wait till the report batch gives response. So this is a time taking process again. So for us, we don't want to wait. We need to get response as fast as possible. So what we can do in ingest is we can insert all of them into a blocking queue. So blocking queue is nothing but it is a kind of transactional queue where only one read happens at a time, or one write happens at a time. No concurrent reads happen, even if there are multiple parallel threads using the. So it is a thread safe queue. So that is what I wrote in this point 4. Ingest is like a producer. It is a very standard problem in operating systems, producers and consumer. So ingest is a producer which keeps adding metrics to queue, this block queue. Also the queue is a block queue, which means only one operation add delete at a time. So even if multiple threads try to add to the same at the same time, only one operation happens at a time. So no data corruption happens or some random error happens. So that is how the ingest works. It keeps on adding into the queue. So and then there is a consumer which keeps running in a separate thread. The consumer keeps looping every second, like you can say every second, and inside the loop it checks if the metrics, if any metrics are in queue. If any, it will flush all the metrics, and it will save into some temporary list, and then it will batch them into 100 or 1000 metrics, and then it will call the report batch method to send those 100 metrics or 1000 metrics at a time. That is how consumer send metrics works. So this is the client side software. In the next video, I'm going to talk about server side software. Thank you. And also please let me know like if there is anything that I have missed or anything you found that is wrong. I would really appreciate it. Thank you.